Afternoon, everyone. Today we will start talking about trigonometric ratio. The first trigonometric ratio that we will be talking about is the sine of an angle. We will look together at the geometry sketchpad investigation, but before we go there, I want you to understand the diagram that you're gonna see there. So you have three triangles there. What is specific to these triangles is that each of them has a 90 degree angle. So angle B is a 90-degree angle. Then the next triangle, angle D is 90 degree, and in the next one, the smallest one, angle F is 90 degree. Good. So that's one thing that we need to understand. Another thing that I need you to see, I need you to look at the three triangles. The big one is B, A, C, goes here, and back to B. So that's my first triangle over there. We all see it with angle B 90 degree. The second one, the red one, is triangle E, D. From D I go to A, and from A I go back to E. Okay, so that's my second one with angle D 90, and the last one, the last triangle that you're gonna see there is GF, the 90, A, and back to G. Okay, so now we all saw the three triangles. They have one angle in common. What is the angle they have in common? The angle they have in common is angle A. They all have angle A there. Good. So now let's go to the promised geometry sketchpad investigation, and let's see what happens here. The three triangles are given, and what I did in each of these triangles, I measured the sides. So in triangle AFG, the smallest one, I measured GF, I measured AF, I measured GA, the three sides of the triangle. Then I did the same thing in triangle ADE. The three sides are given right here. And in triangle ABC, in the big one, as I showed you before, I measured the three sides again. Good. Now, what I will be doing right now, I will be looking at angle A. This is angle A. We see angle A here. And in each of the triangles, I am going to measure the opposite side over the hypotenuse. That's what I want right now. So let's see. In triangle AFG, A is here, is the smallest one. Let's see what is opposite to angle A. Angle A is right here again. What is opposite to angle A is the side GF right over there. What is the hypotenuse of this triangle? The hypotenuse is always opposite to the right angle. So there you go. That's the side, that GA from G to A, that is opposite to the right angle triangle. Good. So let's see what happens. Let's calculate together. Let's calculate opposite. Opposite. I'm going to move this a little bit out of my way. Opposite. Opposite of angle A is GF. So I want opposite over divided by my hypotenuse is right here. Good. I got whatever I got. I'm going to put opposite over hypotenuse right here. Good. I'm going to do the same thing for triangle ADE. Let's calculate together. Let's calculate together opposite over hypotenuse again. Opposite is DE. This is opposite to angle A. So it's DE divided by hypotenuse again, AE this time. Let's see what happened. Quite a surprise. I got the same thing. And now let's confirm my prediction. Let's see what happens when I do in the last triangle, calculate opposite over hypotenuse. Again, this is my opposite divided by my hypotenuse. Boom, boom. There you go. What do I get? Not a surprise. Opposite over hypotenuse is the same. Doesn't matter what triangle I pick. Please notice that if I change the dimensions of the triangle, opposite over hypotenuse stays the same. So what was common in all these triangles? Angle A was common in all these triangles. As a result, I am going back and I will be defining sine of an angle. In this case, uh, I'm gonna use angle B, this angle over here, and I'm gonna say sine of angle B is opposite over hypotenuse. So in this case, sine of angle B will be, what is opposite to angle B? What is the side opposite to angle B? Is this one over here. It's going to be AC divided by, what is the hypotenuse? Angle A is a 90-degree angle. Hypotenuse is always opposite to the 90-degree. So it's that side over there is BC. Now I can talk about sine of angle C. Nothing stops me. Angle C is right here. Again, it will be opposite over hypotenuse. Opposite of angle C is AB. So it's going to be AB divided by the same hypotenuse, BC. There you go. So the definition of sine is sine of an angle. Let's remember that as being very important, is opposite over hypotenuse. Excellent.